Today, we'll be solving LeetCode 543, diameter of binary tree. In this problem, we're given the root of a binary tree, and we need to return the length of its diameter. The diameter is the longest path between any two nodes in the tree. This path might pass through the root, or it might not. What matters is that we find the longest connection, and we measure that length by the number of edges between nodes. Let's look at example 1. We can see that the longest path stretches from one leaf, through the middle of the tree, to a leaf on the other side. That path passes through 4 nodes, which means it has 3 edges. So the diameter is 3. Now let's break down the idea. The key insight is that for any node in the tree, the longest path that passes through it is the sum of the depths of its left and right subtrees. So we want to check every node and calculate that sum. To do that, we need to know the depth of both sides, and we can get that using a recursive function, a depth-first search. Let's walk through how the code works. We begin by creating a variable to keep track of the longest diameter we've seen so far. We'll call it max_diameter, and set it to 0. Then we define a helper function called DFS, which stands for depth-first search. This function will return the depth of the tree at any given node. Inside the helper, we first check if the current node is null. If it is, we've reached past a leaf, so we return 0. That's our base case. Next, we call the DFS function on the left child and save the result in a variable called left. This gives us the depth of the left subtree. We do the same for the right child and store that in right. Now that we have both, we add them together. This gives us the length of the path that passes through the current node, from the deepest leaf on the left to the deepest on the right. If this value is greater than our current maximum, we update max_diameter. To make sure we can update that variable from inside the helper, we use the keyword nonlocal. This tells Python that we want to update the variable from the outer function, not create a new one. Finally, we return 1 plus the maximum of the left and right depths. This value will be used by the parent node to calculate its own depth. After defining the helper, we call it starting from the root of the tree. That kicks off the recursive depth-first search. When everything is finished, we return the max_diameter as our final answer. Let's talk about performance. The time complexity is O of n, where n is the number of nodes. We visit each node exactly once. The space complexity is also O of n in the worst case, due to the recursion stack. If the tree is balanced, it would be closer to log n. To summarize, this is a classic recursive tree problem that teaches how to use postorder traversal, track global values, and combine left and right subtree results. We used depth-first search, updated a maximum value, and followed a clean recursive structure. And that's how you solve LeetCode 543, diameter of binary tree. Thank you for watching, and let's keep learning.